I don't remember if I told you this in the last lecture, but I'm using a program called Screencastify, or not a program, but a plugin, a Google plugin. And it's got, for the free level, it's got a 5-minute limit to the videos, which is kind of a good thing because it means I have to work faster. But it's also annoying because I have to restart every 5 minutes. So in any case, we had answered the first and second question here about the block on the 30-degree angle. We know now the pull of gravity is 196 newtons in total, and then we've discovered that the perpendicular component of that gravity is 169.7 newtons into the plane, and that the pull of gravity that's down the plane is 98 newtons. So we now have concluded that since we expect the box or block to stay on the plane, that the normal force should be in balance with the perpendicular component of the pull of gravity. And so we said that must be 169.7 newtons. Question 3 is, with how much force would you need to push uphill to keep the box at rest on the hill? So without any push, we have a part of gravity that's into the plane that's being counteracted by the normal force. But we have this orange pull of gravity, or orange component of the pull of gravity, I should say, that's in the down the hill direction. And so with no other forces acting on this block, the down the hill component of the pull of gravity will cause it to accelerate down the hill. Like imagine it's a slippery, icy hill or something, you know that this block is going to accelerate down the hill. So with how much force do I have to push on this block? Like I imagine my hand coming in. We're not really supposed to show things in a free body diagram, but imagine that my, I'm pushing, there's my hand pushing on this block, right? I need to push uphill in order to stop the block or keep the block from accelerating down. And so if I'm pushing up the hill, that's going to be a force that is in the negative, as I've defined positive down the hill, in the negative direction. This force needs to be in balance with the down the hill component of the pull of gravity. And so F hand can be equal to Fg parallel, which is 98 newtons. So if I want this to be in equilibrium, that's a word I don't think we've used yet, but if I want it to be not accelerating, then I need to have a force in the negative x direction that is in balance with the force in the positive x direction. Now you can be engineers.